Welcome back to Environmental Science 446, 546. This topic is drinking water and human health. In lecture number 2 for this course, we're going to talk about the human water requirement and how much water we use domestically. In humans, water is essential for several things. That includes most of the metabolic functions in our systems. Water is essential for the assimilation of nutrients and vitamins within our bodies. Water is essential for the regulation of body temperature. Water is also essential for the nourishment of body tissues. Because of that, humans need to consume a specific quantity of water on a daily basis. For instance, the human body itself needs about 64 ounces of water per day. Doesn't seem like much water, but without that 64 ounces, we would not be able to meet our bodily functions of water. But that 64 ounces is really only part of the story. We need water to grow the food we consume. We need water to take care of our wastes. We need water to transport our food and transport all the other things involved in our life. So we use water for a lot. We have a lot of water on this planet. Planet probably should be called planet water rather than planet Earth. But only a small percentage of the water on Earth is considered fresh enough for human use. Let's take a look at a few numbers to substantiate this. Okay, I'm going to put together a table that has two columns. First of all, we're going to look at the location where the water is and the percent of total water on the planet that's in that particular location. The oceans are the major place where water is on this planet. Oceans contain about 97.3% of all the water on our planet. Our atmosphere contains water vapor. Sometimes we see this water vapor in the form of clouds. The atmosphere does not contain that much water. Only 0.001% of all the water on the planet is actually in our atmosphere. The other big place where we have water on this planet are our ice caps and our glaciers. About 2.14% of all the water on the planet can be found here. These three things, our oceans, our atmosphere, and our ice caps / glaciers, account for over 99.4% of all the water on the planet. Well, we still have 0.6% of all the water on the planet unaccounted for. Let's continue with this table and add some more places where we find water. Again, we'll use the same table with location on the left and percent of total water in the right column. We have a lot of saline lakes and inland seas that are not potable, which means we can't directly consume them for drinking. That's another 0.008% of all the water on the planet. We have freshwater lakes. There are a lot of freshwater lakes on the planet. In North America, we have 5 of the largest freshwater lakes on the planet. Those are our Great Lakes. Our freshwater lakes account for about 0.009% of all the water on the planet. Then we have water in our rivers. And collectively, our rivers only account for about 0.0001% of all the water on the planet. We also have soils across the planet, and our soils store water. Collectively across the planet, about 0.005% of all the water on the planet is held as soil moisture. Now, we have some ice caps and glaciers that are within continents. That's another 0.61% of all the water on the planet. So you collectively add up these 5 sources, and that comes to about 0.62% of all the water on the planet. You add that together with the other 99.4% that we identified earlier, and that's our basic water, where the water is on our planet. Not much of this water is fresh and consumable directly by humans. The average American uses about 156 gallons of drinking water, quality water per day. This would include about 135 gallons of water used in a person's residence, and about 21 gallons of water that we use commercially or industrially when we go out to restaurants or we go to gyms or things like that. For a total, that's how we get to our 156 gallons of water used per person per day. If we take a look at this 156 gallons, so of the 156 gallons of water that the average person in the United States uses per day, only 0.52 gallons is either directly drank or used in cooking. So a very small percentage of this 156 gallons we use a day is actually direct contact water, where we use it as drinking or cooking. Very small percent. In municipalities, when you turn your tap on in your home, all the water that comes out of the tap is safe for drinking. But since we only use 0.52 gallons per person per day as far as drinking and cooking, that water coming out of our tap, that 155.5 gallons, is really over-treated for most uses. We don't really need the water that clean for the other things we do. So let's take a look at needs by U.S. citizens, just to give you some more numbers. Again, we have an average domestic water use of about 156 gallons per day. Of that 156 gallons, we only need a little bit less than 2% of that to be first-class quality water, and we'll define those in a few moments. We need about 25% of that 156 gallons to be second-class quality. And the other 73% of the water we use in our residences, we only need it to be clean to about third-class quality. So we don't need the best drinking water for all 156 gallons of water we use. We need less than 2% of it as far as drinking and cooking are concerned. So let's look at our first-class quality. Again, less than 2% of our needs actually has to be first-class water. And this is water that we as humans directly ingest, water we drink. Then we have that category that we call second-class quality. It doesn't have to be as clean as first-class water, and about 25% of what we consume in the home needs to be second-class quality. This is water that's not directly ingested, but it still comes into contact with our skin or tools that we use in cooking. So this is still potable water, but it doesn't have to be first-class water quality because we are not directly drinking it. The other 73% of that 156 gallons of water we use every day can actually be third-class quality water. And this third-class quality water is water that leaks out of our sinks, water that we use to water our lawns, water we use to flush our toilets, water we use in our air conditioning system, water we use to clean our floors, water we use to wash our laundry. This still needs to be good water, but it doesn't have to be first or second quality water. So basically, we really over-treat our water domestically because we treat our water in our homes to very high standards but less than 2% of that water actually needs to be first-class water quality. Let's take a look at the share of indoor water use in the United States. What does a typical home do with the water that comes out of their taps? Well, if we just put some numbers to it, we find that in a typical home in the United States, 38% of the water used in our homes is used in flushing toilets. Another 31% of the water we use is used for bathing purposes. Another 20% of the water that we consume domestically every day is used to wash our clothes or wash our dishes, or about 20%. And only 6% of the water we use in our home is used for drinking and cooking. And then we have some miscellaneous things like brushing our teeth, stuff like that. That's where the other 5% comes in. So in a typical household, if we look inside the house, this is how water use is distributed. Toilet flushing, bathing, cleaning clothes, cleaning dishes, drinking, cooking, brushing teeth, and some other miscellaneous things that we do in the house. Since this is a University of Idaho course, let's go to the state of Idaho and look at some numbers. If we take a look at all the water that we pump from the ground, from groundwater, and all the water we take from our rivers in Idaho, we use about 22,600,000,000 gallons of water in this state every year. Now, if you took that and divided it by the state's population, and I'm a little bit behind on state population, let's just assume that our state's population for this calculation is 1.2 million people. It's actually closer to 1.5 million people today. So if you took our daily water use in Idaho and divided it by the population, that means every person in the state on average would be using 20,060 gallons of water per person per day. Now, what's interesting about this is the highest water use rate in the United States. Now, where do we use this water in Idaho? Let's look at our withdrawals of water by sector. Well, the big gorilla on the block is irrigation. In Idaho, we have about 4 million acres of irrigated farmland. We heavily depend on irrigation to grow our crops in our semi-arid climates, particularly in southern Idaho. So 95% of that 22 billion gallons is actually consumed by agriculture on a daily basis. Industry consumes about 1.9% of the water we use every day in the state of Idaho. The public water supply, the stuff that we send to our homes, uses only about 1.4% of the water withdrawals we have in the state. And we'll just classify the rest of the water as other. So I think it's really kind of interesting that the vast majority of water we use in the state of Idaho is water to grow the plants that we eat, irrigation water. It dwarfs all other water uses in the state. If we take a look at our neighboring states, let's just see how this adds up. If we take a look at the percent of water use in each state that is used domestically, which means it's used in the homes, only 1.4% of the water we use every day in Idaho is used in our homes. If we go to the west and we look at the state of Washington, about 16% of all the water withdrawn from lakes, reservoirs, rivers, and the ground in water, about 16% of it is used in the homes. Now, this is a higher percentage in Washington for a couple of reasons. First of all, Washington has a much higher population, well over 5 million people. So there's a bigger demand for water to be used domestically. And secondly, we don't use as much water in Washington for irrigation compared to Idaho. If we look to the southeast, we look to the state of Utah. About 11.8% of the water consumed in Utah is consumed domestically. One that I think that you will be very interested and surprised in is California. Only about 12.2% of all the water used in California is actually used domestically. There's several reasons for that. One is that California is our largest farm state. California also has the most irrigated acreage in the country. Conversely, California has 37 million people. So that's a lot of water to use in the domestic situations, but still it's pretty low when compared to the overall amount of water that we withdraw in the state of California. And then finally, the last state I'd like to compare is Hawaii. Hawaii doesn't have a lot of irrigated land, and about 11% of all the water withdrawn from the ground from rivers in Hawaii is used domestically. So this starts us out with some information about domestic water use and the amount of water that's required for human use. In the next lecture, we'll take a look at the world situation for water, and we'll also talk about conservation efforts across the world to use less water. Thank you for your attention.